Perspective, Class 1, Video 1. In this video we're going to introduce the topic of perspective and give some motivating examples for why it's such an important topic in mathematics and in the real world. Let's begin by stating the general problem. So the idea of perspective, mathematical perspective, is we want to represent a three-dimensional object in 2D. Okay, simple as that. So we want a way of representing a three-dimensional object in 2D. This is a very general question to ask, how to represent a three-dimensional object in 2D, and it's also arguably quite a vague question. What exactly do I mean by represent? Like, what properties of the 3D object am I prioritizing when I want to represent it in 2 dimensions? Well, we'll answer some of these questions a bit later on, but for now, let's look at some examples of why being able to represent three-dimensional objects in 2D would be useful. Okay, so here are some examples I could think of. The first example is like animated movies or CGI in movies. I mean, if you think about it, movies are entirely a two-dimensional object. They're a series of pictures which your brain interprets and makes a 3D model in your mind. Okay, so animators, when they're making animated movies, they need to know how to correctly display depth in the animation so that the audience viewing it can create this three-dimensional model. Okay, similarly, computer game graphics, like computer game designers, they need to design a world which is three-dimensional. Well, most of the 3D computer game designers need to design a world which is three-dimensional, but the computer games are played on a two-dimensional computer screen. So the game designers need a way of representing this three-dimensional world in a convincing way on a two-dimensional computer screen, in a way which is intuitive for the player. Another more classical example of this sort of problem is in art. Okay, artists often draw or try to represent real-life objects, but their mediums, if they're not a sculptor, their mediums are like canvas or paper. So their medium is two-dimensional. So they need a way of conveying this three-dimensional object on a two-dimensional piece of paper or a canvas. Another application of perspective is in medical imagery. This is a more serious application, I suppose. And the idea is there's a lot of different imaging machines available nowadays where they make 3D models of the inside of human beings, but they need to convey that information to doctors via 2D computer screens. So like MRI, CT scans, X-rays, the output is all a two-dimensional image, but the doctor needs to be able to piece together these output images into a three-dimensional image of the patient's body. So they need to be able to convey three-dimensional information on a two-dimensional computer screen. Another application would be building blueprints or architectural drawings. Like if you've ever been to a building site around campus, sometimes they have nice posters of what it will look like when it's all done. And there's this nice architectural drawing. And these are the same sort of thing, right? They're trying to convey a three-dimensional environment, three-dimensional building on a two-dimensional poster. The same with blueprints. And the final application of perspective that I want to talk about is 3D product design, or I guess any sort of CAD design, computer-aided design. And the idea is, like, if you're designing a product which is three-dimensional and you're doing it on a computer, well, the computer is inherently two-dimensional, right? The screen is just two-dimensional. So you need a way of being able to work with this three-dimensional hypothetical product via this two-dimensional screen. So the product needs to be represented, the three-dimensional product needs to be represented on the two-dimensional screen in a way which is clear to the designer what's going on. So these are the motivating examples. In this module, we're going to be examining the exact mathematical process of taking a three-dimensional object and creating a two-dimensional representation of it. that's the end of this video.